Hello everyone, welcome back. Ultralytics have just dropped YOLO11. Now I am like 4 days late to the party, but better late than never, am I right? Okay, so today we're just gonna look at how it compares to previous models. As you can see on the docs here, they got a nice little chart. And then we're gonna run some of our own tests versing 11 against 10. We're gonna be looking at the inference time, the average FPS, the average confidence, all surrounding live webcam footage, okay? So if you wanna see how it works with still images and videos, we're not going to be looking at that today, I'm sorry, but I will provide you guys the code I'm using to test the live webcam footage, and you can easily change that to suit your needs. Alright, so let's get into it. So looking here at this chart, we can see YOLO11 is just slightly better than YOLOV10, but is still miles better than every other version of YOLO. So I've taken away 3 things from this new update, okay? This update clearly seems to just be revolved around improving efficiency and the accuracy of the model. And also, most notably, they removed the V from the name, okay? I don't know if anyone else noticed this, but I did, and it's annoying. But that's okay. So we've removed the V, really improved the accuracy of the model, and we've improved the efficiency. And so let's put this to the test with our live webcam footage. Okay, so jumping into our testing file here, the way we're going to test this is just by running a normal object detection program, but just some slight tweaks just to make it easier. So we're loading the same modules as we do always, except I've added in time here. This is to help to get the inference time. We've loaded up both the models, so V10 and 11. We've got some list here, that's just for storing numbers. So we're capturing the video webcam, that's normal. Got our infinite loop, okay, we get the frames. We're starting the time of when this while loop starts. We're getting the results. Now the biggest change here, which might catch some of you guys off guard, is this line here. So process frame equals results 0.plot. So what this is doing, in other programs, usually we'll iterate over each bounding box, get the name, get the confidence value, get the XY coordinates, and just manually enter all that things ourselves. But here, since we're just testing and I don't really need that control over the frames, I don't care what the output is, I'm just plotting the results to the frame. So this will plot everything we find onto the frame and then just move on. So we can't really customize it, but in testing like this, it's just not really necessary. So here we've got some just calculations, we're getting the confidence, then we're putting the frames and the inference time in the top left corner, and then we're just showing the frame and escape to escape. So starting off, we're going to test the YOLO10 model, okay, on my live webcam footage. Okay, so now if I run this Python file, we're going to use a YOLO10 model, and let's see the results we get. Okay, there we go. So here we go. Average frames, we're getting what, 14. Inference time, 0.07. Now if I pull in other objects, will it detect it? No. Will it detect this? Yeah, so we're getting cell phone here. What else have I got on my desk? I haven't got much on my desk. Got another cell phone apparently. Got a keyboard here. Keyboard. Watch. Doesn't really detect, that's fine. Alright, just throwing random objects at it. So what worked? So, refrigerator in the background apparently. So the keyboard worked, the cell phone worked, remote. Alright, so we'll now escape out of this, come back down into here. And as we can see, the average frames of the YOLO10, so we're right here. Okay, so looking at these results here, so using YOLO10 on our live webcam, we average 13 frames a second, so we're only able to process a frame, 13 frames every second. Quite slow, very choppy. Inference time, 0.0796 seconds. Look, it may seem fast because that's a very low number, but in the grand scheme, I think it's pretty slow, to be honest. Then we got the confidence. So on average, it was 81.95% confident with the items it found. Okay, so we're going to leave those down there, come back up to here. We're going to swap YOLO10 for YOLO11. Now we're just going to run the exact same code and see how that performs in comparison. Okay, there we go. So it's detecting your refrigerator pretty quickly. It's got me. Alright, throw my phone in there. It's got a cell phone detected. We got controller, remote detected. Detect the mouse. Oh nope, doesn't detect the mouse still. Keyboard. Alright, pretty confident it's a keyboard. Okay, that's enough. Let's see if it gets the watch this time. Does it get the watch? It does. Oh, no, it got it as a bottle, whatever that means. Whoops. Then we just exit out of that one. Now let's look back down here at the results. So looking at these results here, obviously we've got much better FPS we got quicker inference, and this also, the quicker this is, the more frames we get as well. So those guys are kind of like related. Then the confidence value here, so 70.05%. Now it is worse, but if you notice, it did detect objects better. So these confidence values, just don't take them at face value, okay? So yes, we may have got a higher confidence score in the YOLO10, but it also detected less objects. With YOLO11, we detected way more objects. Obviously, the confidence there is obviously going to be lower because it's got a lot more to detect, and on average, it's not going to be that confident, especially since we're using just the base trained YOLO model. We haven't trained it specifically on detecting anything. But taking away from these results, honestly, so YOLO11 compared to YOLOV10 for live webcam footage object detection, definitely YOLO11. So I had this program running on my MacBook, M2 chip. It's decent, okay, but obviously for things like machine learning, AI, etc., it's not really going to cut it. So obviously I'm not going to get the best results, but if you were to use these on your desktop, you would see much, much better improvements in speed overall. So yeah, YOLO11 for live object detection wins, okay? YOLOV10 obviously still good, and YOLO11 is based off of V10, but definitely if you can use 11, use it. And just before I end this off, I'll quickly show you guys how to actually upgrade from YOLO10 to YOLO11. So to upgrade from YOLOV10 to 11, assuming you're in an existing virtual environment that hasn't been updated yet, all you want to run is just pip install ultralytics, essentially installing it again, except at the end we're just going to put -- upgrade. Okay, I'll leave that little line of code down at the bottom, but you run this first things, it will update your ultralytics, and then you'll have YOLO11n.pt available for use. Thanks for watching this quick video, guys. Hope you enjoyed. Please leave a like and a subscription. It will mean a lot to me. And I'm currently working on a huge tutorial, okay? And we're going to be moving on from the base code that we made back in tutorial 1, and we're going to just optimize the hell out of it and follow a lot of the OOP principles, making it much more efficient and honestly just a lot more visually appealing to look at. So I'll see you guys then.